This video focuses on software deployment as another one of the TaaS framework automation services. Again, after discussion of the characteristics of this service, an interactive demonstration follows to show some of the software deployment features based on sample implementations. The general characteristics of automation services in the Topology as a Service framework have already been discussed in the video that presented the provisioning service as the first example. We can skip this here. Now we look more closely into the second one of these services, namely software deployment. As will be shown in the following demonstration, an application's software artifacts must be uploaded to a repository in the TaaS CMDB before they can be used in deployment. This can be unrelated versioned deployment units, or preferably versioned application releases that enclose a set of versioned deployment units. Deployment of an application is modeled in a deployment template, which is then instantiated on a fitting infrastructure topology instance and executed. Very often, deployment execution can happen repeatedly on the same infrastructure after minor code changes to all or some of the deployment units, and after upload as new versions to the repository. After deployment execution, an application is immediately running, and no further steps are necessary. The service takes care of orchestrating all the tasks across the entire topology. This encompasses the transport and installation of all deployment units on all their destination nodes, as well as all the necessary configurations anywhere in the topology and the update of the ecosystems. In order to demonstrate the deployment features of Topology as a Service, we look again at a very simple example using the Demo3 topology that we created earlier. If we instantiate that for this demo, we choose again a scalable tier with more than one node. Provision that, and while this happens, let's look at the deployment artifacts as they are stored into repository. We can have either individual deployment units or entire application releases that then can be added to topology templates to create deployment templates. So in this case, we will look at a simple example. An application release that just has a hello world servlet to deploy. So we add that to the canvas where the topology template exists and wire that up. A deployment unit has several properties, just a name, typically an ID. It belongs to an application, and it has a versioning as well. In addition, it has a type, which is reflected in the topology as a outgoing connection type. In this case, it comes from the Java Enterprise realm, is set as JWAR. In addition to that, custom properties can be specified. In this case, a log file path just relevant for this deployment artifact, which we log to a my debug log in the temp directory, as one example of custom properties. This is now a deployment template that we can upload, name and upload to the CMDB. So we call it something like Demo3 hello debug, give it a version, major, minor. And in addition to that, we can also specify some ordering of the deployment steps. There are always two tasks. One is the transport of the artifact to the target server. The other one is the install task to really install the artifact on the target server. Transport tasks quite often can be totally in parallel. Since they don't depend on each other, the artifacts can be transported anywhere, but we could also choose to make sure that all the transports are finished before the first install starts. Or we can say we link it entirely to the install sequence, meaning that transport and install per host happen together. The install task itself can again be specified as parallel, which in this case, since it's a very simple hello world that doesn't depend on anything, can make sense. So we can install it in parallel on all the nodes that we go to. The default is usually reverse communication serial, meaning that nodes that follow in application communication links are installed to first before the node with the outgoing communication is installed to. We could also say everything happens in parallel, but with serial rolling order in scalable nodes, so that one node after the other in the scalable nodes gets installed too. And finally, we can combine the two, reverse communication serial with serial rolling in scalable. Then we can say upload it to the CMDB, which means it will appear in the deployment templates that we have at our disposal. There it is, our Demo3 hello debug with just the hello debug Word file inside. So in order to use that, we can go to our freshly provisioned instance of the Demo3 topology, which took 24 seconds, by the way, for these two fresh VMs and WebLogic servers running inside and the load balancer set up. So in order to use that, we instantiate the deployment template inside the topology instance. Again, we could choose a special order this time, not just a predefined one, but we won't do that. In addition, we can specify which release of that application should be used. By default, it's the latest release, but we could also say that we want to choose a specific release for the deployment. This time we are fine, take the latest release, and it adds the instance of that deployment template to the topology instance with exactly the same structure. So in order to really deploy, we have to say deploy that instance, execute that. At execution time, we can again choose certain properties. In this case, we can choose to transport and install or do only one or the other. And we can filter according to either all the DUs get deployed or we do it incrementally so that only those deployment units are deployed to destination nodes where they are not yet installed. So this time we want to do all of them and transport and install. Start the task to do that. It's very fast, 2 seconds, and the hello debug servlet is deployed in the 2 target servers that we have in our topology instance. In order to try that out, we can again use a predefined button on the load balancer. So we go to port 8000, that was again the first one allocated, call that hello debug servlet, which does nothing else than writing out hello and tells us on which server it is actually running. So it's running on the clone 1 And if we reload it, it goes through the round robin and goes to the web node inside. In order to demonstrate quickly what happens if we scale that scalable node within the topology, let's just so we can say we go to 3 again, which means it will provision a third node inside the elastic tier and will then redeploy the WAR file that is wired up to the topology node here in order to reach a state where all 3 nodes inside the elastic tier have the servlet installed as well. So that already happened. It has been deployed 3 times, transported and installed, also on the newly created nodes during the scaling operation. Scaling operation took 24 seconds. So if we go again to the test and try that out, we just did it the first time, so it goes to the clone too. It has been correctly deployed and all the 3 nodes probably will be working. Clone 1 as well. So round robin goes through all 3 of them. At this point in time, we could now go ahead and change something in the source code of the hello debug Java file during development, of course. Use the development toolchain to create a new application release and upload it to the CMDB. And then say in the scheme here, just redeploy of the release, which takes always the latest release as we have set it. And that will then deploy the newly changed application, and we could try it out again. That gives a very quick turnaround of changes to try them out, especially if you have something like a WebLogic server running that is able to accept replacements of WAR files or jar files or e-files while it is running. So, well, not even a reboot is necessary. Once again, when we are done with using that topology instance, we give the space back and clean up by deleting the topology. And everything disappears again, and the side effects get destroyed. To finish this demo, let's have a quick look at the very simple log file handling that has been set up for these simple examples here in the Topology as a Service framework and its customizations. So every node that gets created within this elastic tier, when it starts up, it registers its log files according to the log path properties that have been set for the node to a file beat running in the operating system of that node. So we are using FileBeat and Logstash just in a very simple setup. The deployment unit, as we have seen, has a property set for its own log file path that registers a temporary application log file to the path, which will then be at the install time registered to the FileBeat. All these log file records will be sent to a central place, in this case a Logstash running on this computer. We see here a simple tail output of a common log file that's being written by Logstash centrally. So if we scroll back a little bit, we see that on the newly created clone 2, the operating system has registered a boot.log file from which the records are sent to the central place. And if we really go to the end, we see that also the application, which was called in our round robin scheme for testing things out, has sent its own records to the FileBeat from where they reached the central place, so the hello from servlet. The actual registration of the log files happens for the nodes during standalone configuration and for the deployment units just before it's actually installed in the install step of the deployment unit.